of instructions, that is data transfer, arithmetic, logical, program branching, bit manipulation, and Boolean instructions. So after the various instructions, we will go for the last part from this, which is actually not included in syllabus. We will consider as content beyond. So assembly directives or directives used by 8051. So the assembly directives are nothing but some are similar to the instructions but not instructions. Simply we say that the dummy instructions or pseudo instructions. So as these instructions or directives does not carrying the memory location in the uh, memory of an 8051, and in most of the cases some directives are optional, that is as per the choice of an user, and some directives are uh, mandatory or necessary. So based on the function or requirement, we will see here the assembly directives generally used to define some symbol, characters, strings, or specific uh, message if you want to display in consecutive manner or successive manner, generally in case of string, and that too related to the ASCII numbers or ASCII values. So here 8051 supports the four major assembly directives, that is first one is org, second end, third equ, and fourth is db. So org directive and end directive, these two directives are mandatory while writing an assembly language program for 8051 microcontroller, and next two directives are optional, that is equ and db, define byte. So these two are optional. As per requirement or choice, we may write these two directives. Okay, so these are the, suppose we consider the instructions but actual not instructions, we will write similar to the instructions as we write the instructions, but their function is something different, like they couldn't occupy the memory space like instructions loaded in the program memory, and whenever we required or modify the content, it is easier to use these kind of directives. Okay, so as per the function, some mm, directives, like first we will see org is nothing but origin directive, that is after writing org directive we will start our assembly language program, and after org whatever number you have mentioned, suppose it is 0000h, so your program will start from this memory location onwards, that is 00h onwards, and further instructions are written after this directive, org directive. So to indicate or specify the starting memory location of an program, we will go with the org directive. So if you want to start your program other than 00, that is starting memory location, we will go with, suppose second example, that is org 0100h. So if you write this directive, that is 100h, in this case your program will be started from 0100h onwards. So here initial memory locations we don't care, or CPU assembler will don't care what it is written, but it will start executing the program from that memory location you have specified at org directive. Okay, so this is the directive used to specify the starting memory location always, and it is not related to always starting with the initial memory location, that is 00. It may start with the any other memory location within the memory size available with the microcontroller, that is 8051. Internal is 4 kilobyte, and if you have connected external, then internal plus external should be equal to or less than 64 kilobytes. Okay, so this is the instruction where we can define or specify the number, that is memory location, either in hex value, either in decimal or in binary. So here three numbering systems are used. Binary numbering system, you have to specify, if you define 8 bit, then 8 0101 bits, considering LSB side and MSB side. If you consider the hexadecimal value, then you have to write the hexadecimal numbers 0 to 9 and A to F. So according to as per the requirement, or according to your size of program memory, you have to select the starting memory location, either in hex or last part is decimal. Okay, so in this case you have to specify your starting address, that is memory address related to org. After that, next directive is end directive. Here the end directive is used to analyze or predefine the end instructions of an program written in the 8051 assembly. Okay, when we write in assembly language, so whenever this instruction, that is directive, comes, that is END, either in small or capital letters. So further, if you have written any instructions or some operations, they are not executed by the assembler of an 8051, because it will consider that after end nothing will be written in a program memory. That is, after end directive, further instructions are not executed by an assembler of an 8051. So end directive indicates that end of your program. So after that, no instructions are written. If you have written but they are not executed by an assembler, so whenever you write end, you didn't write or need not write any kind of instructions. If you required the further instruction, then you change the directive position of end. So end is the last instruction written in ALP, that is assembly language programming, and here only end is sufficient. It is not necessary to mention end 100H. So end memory location of an program memory, so it is not required. So you have to write only end. It will automatically consider that this is the last instruction from your assembly language program. Okay, after that we go for next instruction, that is or directive, sorry, EQU. EQU is nothing but your equate. Okay, and EQU instruction or directive is used for defining some constant number or constant value. Okay, so if we consider the example, that is I have mentioned data EQU 20H. So in this case 20H is your number or constant number, and which will be assigned to the data label. So if you consider data as a label, and for that the value assigned is 20H, hex value 20H, and due to the EQU, that is equate, data is equated with the value 20H. So whenever onwards, after this, whenever, one minute, whenever this is to be used, simply remove, whenever this instruction is used, so after that when, if you write or you required multiple times that number, that is 20H, for different application or operation, so you simply go with the EQU directive by specifying some label. Suppose it is here, consider data is an label or value associated with data is 20 by the execution of this instruction. So whenever after this, if you write any instructions related to the value required as a 20H, so I have mentioned A already. Data again. Data. So in this case, if you execute this instruction, so whatever the contents belongs to data are simply copied to A. And again, if you want to load 20H in another register, to, that is suppose R5, again it will copy like this, move R5 comma hash. If you like this B comma hash data. So it is feasible when we required multiple times, same number or value required multiple times, case one. Or second case is that when we want to change the number, suppose right now you required 20 as a number which will be perform some operations, that is suppose and or whatever, or by comparison C chain is there, but after some time or after some days this value may change, 20 becomes 30. In that case, if you have written in regular or routine purpose, like we say, we consider instead of writing that 20H, of using EQU directive, if you have simply use the required value. Okay, so this is your routine. You have copied 20H to A, copied 20H to R5, and copied 20H to B. Okay, but after some time or after some days, whatever, or time interval, if you want to change that number, that is 30, in that case, you should go each and every instruction whenever you want the content need to be changed 30 like this. Okay, this is somewhat hectic job when we want to replace the single number, that is 20 is replaced by 30. And if you do not use this instruction, in that case you have to make changes for each and every instruction whenever that number is used or required. But if you go with this instruction, that is EQU, in that case you have to simply change, that is earlier it is 20, now it is 30. Okay, so only one change need to be done from user side, that is data EQU 30H. So in this case, if you change only here, it will automatically consider the change in all remaining instructions whenever it is used, that is data. So for this purpose, sake of simplicity and to save the time, we use this instruction, that is EQU. Okay, so this is required. I will check. Waiting, no. Why strength is so less today? 37 only. Okay. So EQ directive is clear to you?
Yes, sir.
Okay. Not sorry. 50 are there. 37 are the messages. Okay, so after this EQU, we will go for the define, db define byte. Who is this? Sutar. Okay. So this is a most important directive, as mostly whenever we want to send the message on the LCDs, that is LCD display, with some special characters, symbols as a decorative purpose, or some units are there. Okay, in this case, this directive plays an important role. That is, whenever we want to simply consider the ASCII value. Okay, so here ASCII value, if we want to transfer on the some device, that is, we simply consider example of an LCD display. Have a good day, good morning, whatever the messages are there. So in that case, if you want to transfer this message it is better to use the DVD. DB is nothing but defined byte directive. So it is an 8-bit directive, that is which is used to transfer the 8-bit data, and whenever we want to transfer the contents either in decimal, binary or hexadecimal, we are able to transfer with the help of defined byte directive. But most of the cases, whenever we require to transfer the ASCII characters, that is numbers, special characters, symbols, whatever, so simply we say that the ASCII characters, in that case we prefer the defined byte directive. And to indicate the ASCII value, it is necessary to mention that particular content which are required in a quotation mark, either in single quotation mark, opening and closing, and either in double quotation mark. So quotation mark you choose as per your choice, either single or double. So whatever the contents written inside the quotation marks, they are considered as ASCII characters or ASCII string. So suppose good day. So whenever we want to define or transfer the values, characters on the display, we simply consider the display. In that case, we consider defined byte directive. So here in example, it is mentioned that DB20. So here 20 not mentioned by any other specification, that is binary, decimal or hexadecimal. It will consider as a decimal number. But if it is mentioned H, then hexadecimal. So it will assigns the memory location for that. And after that, whatever the contents belongs to that, that is G, O, O, D, D, A, Y, whatever. So these are the ASCII characters loaded from this 20H onwards. So whenever we requesting to the ASCII values, we will consider our memory locations starting from 20H, and it will copy one by one ASCII characters and it will transfer to the required output device. So this is related to the defined byte directive. So in case of 8051 directives, mostly 4 directives are used. Out of that, 2 are mandatory, org and end, and remaining 2 are optional as per the user requirement. So this is regarding directives used in 8051 microcontroller. If you have any query related to that, please ask. Hello?
Yes, sir.
You have any queries? See, you are seeing on the screen. Who is this Rajan Dubal? Again. You people always try to make mess in the class. Okay. So now we will discuss related to some of the examples related to the instruction. Okay. So as you have gone through the various instructions, we will see some of the examples related to the data transfer, and answers will be from your side. Okay. So see, suppose consider that we have to transfer the 20H content stored at B register, and we have to transfer this content on R7 register. So which instructions need to be used or written?
Move R7, B.
R7, B. Okay. So Prajakta, you give an answer right, but you keep mum for some time. Whenever required, I will ask. Sorry, huh?
Okay, sir.
So next, related to the, suppose we consider we have to transfer the 05H content loaded at accumulator into the memory location 20H. Okay, listen. We have to transfer 05H content which are loaded in accumulator onto the memory location 20H. Which instructions need to be preferred or transfer the content from accumulator to the memory location? Anybody else? Roll number 14, are you listening?
Yes, sir.
Please answer.
Move
Move.
R, comma A.
1 minute. I will start with Excel sheet. Let us see, if we are having A is equal to 05H and need to transfer at 20H, that is memory location. Memory. Which instruction? Move.
Move R, comma
R only. Okay.
A.
R comma A.
A.
A. So what indicates R?
Register.
Which register? Only R. Hello?
Yes.
Anybody else? Roll number 30 is there? Hello? Roll number 30. आहेत का? लॉग इन तर आहेत. Hello, are you listening? Roll number 30.
Yes, sir.
बरोबर आहे का instruction? Move A comma R. Sorry, move R comma A. If I have initial content at A 05UH content and need to copy it at the memory location 20H. त्यांनी सांगितलेली instruction बरोबर आहे? हॅलो, इथं जाईल का 05? हॅलो,
हाँ सर.
instructions क्लिअर आहेत? डेटा ट्रान्सफर आन्सर काय बघा यांचा? तुम्ही सांगितलं आता, मी कोणाला विचारलं होतं? 15 ना? Next. This. Gopal. Are you listening? 48. Hello? Roll number 48.
Yes, sir.
हाँ. हे सांगितलेली instruction बरोबर आहे का यांनी?
नाही सर.
हाँ, मग right instruction सांगा. Please. Other than that. Kaustubh, are you listening? Instruction
Yes,
बरोबर आहे
sir.
का ही?
सर आय एम बाहेर पडलो होतो सर, नेटवर्क गेल्यामुळे ते काही कळलं नाही परत.
आता स्क्रीन दिसते समोर.
हा.
कंटेंट काय आहेत? ए मध्ये
सर मी सांगू दे का?
1 मिनिट. 05H आणि ते कुठे लोड करायचे? मेमरी लोकेशन 20H. जे काय मेमरी आहे तिथं लोड करायचे. ओके. त्यासाठी अर्लियर आन्सर काय? मूव आर कॉमा ए. त्यांच्या म्हणण्यानुसार ही इन्स्ट्रक्शन यूज केली तर एचे कंटेंट 20H ला जातील. ओके. आता कोण होतं आन्सर सांगणार? प्लीज सांगा. हॅलो
सर पहिला मूव R0, 20H करायचं, मग मूव ए कॉमा ॲट द रेट R0 म्हणजे
पहिलं काय
20H
करायचंय?
मध्ये ते एच 05 असलेली व्हॅल्यू लोड होईल.
एक मिनिट, स्टेप बाय स्टेप सांगा. मूव R0 कॉमा हॅश 20H. गुड. त्याच्यानंतर
मग मूव
ए
मूव ए कॉमा हॅश.
@ R0.
नाही.
बोला हर्षल प्लीज. हॅलो.
एक्सक्यूज मी सर.
या.
सर क्वेश्चन रिपीट करताल का?
बघा, इनिशियल कंटेंट्स बिलोंग्स टू ए.
मूव ए कॉमा ॲट द रेट R0.
मूव ए कॉमा @R0. ओके. क्वेश्चन काय, ए मध्ये ऑलरेडी 05H आहे आणि ते आपल्याला 20H या मेमरी लोकेशनला लोड करायचे. हा क्वेश्चन आहे. कंटेंट्स बिलोंग्स टू ए इनिशियली 05H कंटेंट आहे, डेटा बिलॉंगिंग टू ए, आणि तो पाहिजे आपल्याला मेमरी लोकेशन 20H इथं लोड करायचं आहे आपल्याला. ओके. आता फ्रॉम
कॅन आय गिव्ह आन्सर?
wait. So as for the Harshal's point of view, initially we have to identify the memory location and we should assign the memory location, that is indirect addressing mode, right Harshal? बरोबर. move R0 comma hash 20H. R0 ला आपण मेमरी पॉइंटर करायचंय, त्यासाठी 20H घेतलं. ही इन्स्ट्रक्शन क्लिअर आहे किंवा राईट आहे? याच्यानंतर इथं आता आफ्टर एक्झिक्युशन ऑफ दिस इन्स्ट्रक्शन रिझल्ट
ए मध्ये जाईल ते.
ए मध्ये जाईल. मग आता आपल्याला
रिव्हर्स करावं लागतंय ते.
रिव्हर्स करावं लागते. गुड. हेच अपेक्षित आहे. कॉमा ए. आता काय होईल, तुमचे कंटेंट ऑफ ए शुड बी कॉपीड इन टू द मेमरी पॉइंटर R0. आणि मेमरी पॉइंटर R0 म्हणजे काय, त्यांनी कुठला पॉइंट केलंय 20H ला. इथं काय जाईल आता 05H. राईट. गुड हर्षल, थँक्यू. नेक्स्ट आपण ऍडिशनचे काल जे बघितले.
सर आपण हेच डायरेक्ट ॲड्रेसिंग मोड करून पण यूज करू शकतो ना?
सांगा. मूव
20 कॉमा
20H
कॉमा ए.
याने पण होऊ शकतं. नो प्रॉब्लेम. सी, इन बोथ केसेस इट इज applicable. Here we have used to specify the address with the help of indirect register, and then we go for the transferring the content either from this to this or this to this. No problem. Okay. And in this case we are using directly the memory pointer 20H A. After that, if you required 21, in that case you have to write like this 21. Again, if you want to write further, see what I am telling. Suppose in 22. आता या तिन्ही केस मध्ये काय 20, 21, 22 प्रत्येक वेळी तुम्हाला असा मेमरी पॉइंटर डिफाइन करत जावं लागेल. जर इंडिव्हिज्युअल वापरत असाल तर, किंवा हे तीनच आहे, नो डाऊट 3 इन्स्ट्रक्शन्स वाढतील. पण याच्यानंतर असंच कंटिन्युएशन मध्ये असेल 3चे 10, 100 वॉटेवर काय असतील ते. ओके. त्या केसमध्ये तुम्हाला रिपीटेडली इन्स्ट्रक्शन्स राईट करावं लागेल, मेमरी कन्झ्युम होईल. पण लिमिटेड ऍप्लिकेशन असेल तर इट इज गुड किंवा ओके. बट whenever we go for the multiple operations and that to consecutive in the sense of 21H. आता हे 21H झालं. तेच येते का? सॉरी, कन्सिडर कर 21, 22, 23. या केसमध्ये जसे आपले ऑपरेशन्स वाढतील, इथं या सगळ्या इन्स्ट्रक्शन्स लिहायच्या पेक्षा आपण काय करणार, मग हा मेथड यूज करणार लाईक दिस. आणि त्याच्यानंतर मग इन्क्रिमेंट R0 आणि मग परत काय करायचंय, DJNZ वॉट एव्हर तुम्हाला जे काही ऑपरेशन्स पाहिजे असेल ते करू शकतो आपण. ते आपण नंतर पाहूच. ही पण मेथड बरोबर आहे जर तुम्ही 1 or 2 मेमरी ऑपरेशन्स करत असाल तर. बट whenever we go with the several operations, म्हणजे सक्सेसिव्हली डेटा लोड करायचा आहे, सक्सेसिव्हली डेटा रिट्राईव्ह करायचा आहे, त्या केसमध्ये काय करायचं आपल्याला, इनडायरेक्ट ॲड्रेसिंग हा बेटर असेल, पण तुमची कोड साईज जी आहे ती कमी कमी होत जाईल. म्हणजे एवढ्याच 3-4 इन्स्ट्रक्शन केल्या, म्हणजे इथं हा डिफाईन केला, त्याच्यानंतर एक काउंटर इथं डिफाईन केला, 10 तुम्हाला ट्रान्सफर करायचे. मूव R2 कॉमा हॅश 10 एन म्हणतोय तर 0AH. ओके, 10 कंटेंट आहे, 10 तुम्हाला ट्रान्सफर करायचे. मग हा झाला तुमचा काउंटर 10चा, हा ॲक्च्युअल मेमरी पॉइंटर. मग एचे कंटेंट इथं टाकले, परत इन्क्रिमेंट R0 आणि त्याच्यानंतर DJNZ R2 कॉमा सपोज अप केला इथं, तुम्ही इथं देऊ शकताय अप, बरोबर ना? See, in this case, whenever we consider the multiple operations, that is after 20, next operation 21, 22, 23, like this. Number you decide or as per your requirement. So according to that requirement, you have to analyze the counter value. So here we consider 10, so 22, suppose 29. Okay, so in this case, till this we required the values should be loaded, and that are not always from the same register or same value. So simply increment this, load again accumulator with some another memory location, another register. Okay, and you have to use this instruction, DJ and continuously. आता हे जे आहे ते किती 1 2 3 4 आणि 5 इन्स्ट्रक्शन जातील. यातल्या हे सिंगल 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 हे फक्त 2 ला असेल, 2 मशीन सायकल्स किंवा बाईट, आता एवढेच जातील. त्याच्याऐवजी जर 10 इन्स्ट्रक्शन्स वेगळ्या लिहिल्या असत्या तर त्याला एक एक बाईट म्हटलं तरी 10 वेगळ्या गेल्या असत्या, आणि मग इनिशियलच्या तर 2 लागणारच, ए आणि R2चे. म्हणजे 10 ते 12 इन्स्ट्रक्शन यूज करायच्या ऐवजी जर 5 इन्स्ट्रक्शन मध्ये काम होत असेल तर तुमची कोड साईज रिड्यूस होईल. त्यामुळे तुम्हाला ॲडिशनल आणखी फंक्शन पाहिजे असेल तर करता येतील. ओके, सो दिस इज रिलेटेड टू द डेटा ट्रान्सफर. Again, if we consider related to the suppose addition, in this case, if your contents within 8 bit, no problem. But if, as I think we have seen the yesterday example, if result is greater than 8 bit, in that case your carry flag is generated, and according to that, if again we perform like subtractions. For subtraction, borrow related to instead of saying carry, we consider the borrow, and then next part is related to the BCD additions. So as you have done in the DT, that's digital techniques. So for BCD addition, if result is greater than 4 digits, greater than 9 for lower nibble, greater than 9 for higher nibble, then you have to add manually. You have to add 6 at lower. If it is at higher, that add 6 at higher. If it is at both cases, add 6 to the answer. But in case of 8051, one instruction is there only, DAA. So you need not to perform the multiple operations to adjust the